You know, as a kid, like I probably, like everybody else around here, started as a high school space nerd, you know, science fiction nerd. You know, chess club, as sad as that might be, chess club, you couldn't get access to the computer. We only had one computer in my high school. It was an Atari 400 or something like that. And the only way you could get access to the computer was if you joined chess club. Okay, so that's kind of the path of destruction for me. Started out being interested in advanced technology right from the beginning, although that wasn't really a path I was good at, right? I wasn't an engineer by, you know, training or anything like that. So started out as high school reading science fiction.
Did you eventually get training as an engineer?
No, I didn't. I'm actually a finance guy. Finance, marketing, investment management, real estate, that sort of thing. I just have an interest and passion for it. I've always kind of tackled advanced technology. I think I started my first .com in 1996, so, you know, pretty far ahead of the curve. And space is kind of, I don't know, maybe the coolest thing out there, so, you know, that's what I tackled, yeah. You couldn't do space stuff 15, 20 years ago. There really wasn't anything an individual could do, so I kind of had to feel like I bided my time until the day, yeah.
But now you are involved in at least 2 different projects that are very heavily involved with space. Yeah. First of all, let's talk about nanotube technology and space elevators.
All right. So I started out, I'm going to give you like the 11-year version in 2 minutes, okay? So obviously I'm leaving some stuff out. But you know, we started out as a NASA Institute for Advanced Concepts research team in 2001, looking at the space elevator. And the reason that even came up was NASA's official position was, quote, 300 years or never. That's what they thought about the elevator. In 1999, they said 300 years to never. And for NASA to come out and say something was impossible, that just didn't feel right. So there was a new technology that had just recently been discovered, carbon nanotubes, and they have, you know, pretty fantastic mechanical, physical properties. They're incredibly strong. And so the idea was, okay, if you can scale that technology up, you can change the world. So we started out under, I was the second guy on the project, and we stayed under NASA's umbrella for about the first 2 years or so. We had completed a phase 1 and a phase 2. That's NASA speak. You know, we have first level funding, second level funding, and then there was no follow-on funding. So we had made, I think, 4 or 5 trips to NASA headquarters to try and figure out where we fit within the hierarchy, and there wasn't a good place, and that's why we had to make so many trips. But while all that was happening, the Columbia crashed. The Space Shuttle Columbia crashed.
That led heavily to their decision to cancel.
Yeah. And you know, that was a good decision for NASA. It was a terrible decision for us. But, you know, they had to get their birds flying again. So when that happened, people started sending us emails saying, you know, there's got to be a different way. There's got to be a better way. And at that point, we kind of had to make a decision of either, you know, submit the binder and just put it on a shelf and call that paper a done study, finished it, or take what we had learned, build a company, and start building an elevator to space. And that's what we did. That's what we did. I said my background's in real estate and investing. I'm not going to say I'm rich by any stretch, but at the time I was relatively comfortable. I'm 44 now, so I was in my early 30s. Honestly, I had to work maybe 4 hours every 2 weeks, so I had the time, and I had the capital, and I wanted to do this thing, and I started using my own resources. I used a little bit of other people's resources, but mostly it was my own checkbook. And I built a team of about 14 people. Everybody was badly paid. You know, it was a startup. It was a startup like any other. And we built this thing. And at first we started out on carbon nanotubes, and we honestly weren't very good at that. Then we switched to robotics and balloons. And so what we would build is high altitude balloons tethered to the ground with robots climbing back and forth. And that was great. We were making some really good progress. We had something like 60 universities involved and maybe 700, maybe 900 people around the world working on different aspects. So we were tackling internally one discrete part, but then around the world, people were looking at different aspects. Things were going good. We were a catalyst. It was nothing. It was a carbon fiber. Sorry, it was a fiberglass composite. There was nothing particularly interesting about it. We weren't aiming for strength. We were really focusing on the robot to climb.
You did do several test flights, though.
We did. We built 19 robots, and we had 14 flights. So Air Force, Navy, FAA all have to kind of agree that, okay, we can have this bubble of airspace and have a robot climbing up and down. So we got up as high as a mile. We were working on a 3-mile high system. And 2007 happened. My wealth came from real estate. You can kind of see where this is going. I made a conscious decision. I literally bet the mortgage on the project. So the math didn't work out very well. So I lost most of my assets. Let me rephrase that. I lost all of my assets, and everything just kind of collapsed, and it was pretty ugly, and it happened really, really, really fast.
How did you recover from that?
My mom says I still haven't, so it depends on how you want to look at that. It was tough. It was really tough. I really had to kind of look at myself in the mirror and decide whether or not this was even important to me. If I could go back and make buckets of money in investments, I was good at it, or I could do the thing that I actually cared about. And so I went off to school. I did a lot of really kind of dumb, random projects to kind of pay the bills. And I just couldn't give it up. So, my one true love is this elevator. So just about 6 months ago, I restarted. And that feels really good. Now, our new system is not the same as the other one. We still can't build an Earth elevator. We just can't do it. I'm kind of a smartass, and I kind of refer to it as hunting Bigfoot. We need a special material that they can produce in a lab. They can't mass produce it. The quality control is terrible. And as of today, we can't build an elevator on the Earth.
So if we can't build it here, where can we build it?
Build it on the moon. So as soon as we kind of like got out of our rut, out of that myopic mindset, as soon as we let that go, the whole solar system opened up to us. You can build a lunar elevator with current materials, that's the key, current robotics, current rocketry, current communications. Basically, you can purchase order just about every component of the system.
What would be the anchor, the orbital anchor for it?
So let me go back to the Earth elevator for a second. So the Earth elevator is, imagine you have a ball on a string, spinning it over your head, right? The string in the middle stays straight. Expand that to an Earth-sized system. The Earth rotates. You have a counterweight, a satellite deep out in space with a very long, very strong string. All the mechanics are still the same. So as the Earth spins, that string will stay straight, and you can climb back and forth like a railroad out into space using a robot, not a rocket. The lunar system is a little bit different. It doesn't have the same rotation, blah, blah, blah. So here's the Earth, here's the moon, and the Lagrange point is kind of where the balance of gravity from the Earth matches the balance of the gravity from the moon. I'm simplifying. So what you can do is you can get to the Lagrange point with a normal traditional rocket and then use an elevator down to the surface of the moon. It's a pretty short distance. And what you've really accomplished there is soft landing on the moon. that doesn't sound all that interesting until you look at the Saturn V. Sorry, I lost the name for a second. It just kind of slipped out. Until you look at the Saturn V, the number one driver for how big that rocket is was fuel. Fuel to slow down at the other end, soft land, and then get off and come back home. So if you take the soft landing component out of the equation, everything else gets simpler. So any rocket that can launch to LEO and push out to GEO, the math is really simple. If you can push to GEO, you can push to the Lagrange point. So what does that mean? That means any nation, any company, any university that can launch to low Earth orbit can now soft land cargo on the moon. That's a fundamental change. We haven't had that capacity in 40 years. So that's what we're building, and yeah, it feels pretty good.